In this video we're looking at some important words for statistics. Univariate. That means examining data that only involves one variable at a time. For example, student height. Or it could be student width. But we wouldn't be looking at both of those together. The next one is population. In a population, everything, item or person you want to collect data about is included. So for example, if I wanted to know the heights of all the Year 9 students at CSC, the population would be all the Year 9 students at CSC. Measuring the heights of every student at CSC would take some time. And because of that, we usually sample the population. In a sample, you look at some of the population, measure some of them, or ask some of them how they're going to vote if you're looking at voting patterns for an election. So for example, if I wanted to measure the heights of students in Year 9 at CSC, I could sample this by choosing to measure students in 9G and hoping they represent the population well. Making sure you've got a good sample is one of the hardest things to do in statistics, because you want to make sure that the people you do actually ask represent the entire population. So let's look at a few different types of sampling. A random sample is when you choose data by using a random method. And this usually involves rolling a dice to decide who is measured, or using a computer program to generate random numbers, which then decides who gets picked. The key thing in a random sample is you need to make sure you've got enough people randomly chosen so that they represent the entire population. The next type of sampling is called stratified. In a stratified sample, you make sure that every group within the population is sampled at the same proportion. So for example, if half the population of Year 9 at CSC are girls, when we took a sample, we'd want to make sure that half the people we actually sample and measure are girls. That would be a stratified sample. The next one, biased sample, is what happens when things go wrong. So for example, if I was trying to measure the heights of students in Year 9 at CSC and I only measured the 14-year-old students, you could imagine that the 15-year-olds would be a bit bigger, and so therefore my sample would be biased and I'd get a lower value for all the heights than I could expect to if I measured everybody in the entire population. The last thing is a survey. A survey is when you ask questions of a sample to get information or data. A census is when you ask the entire population. Everybody gets asked. When we're collecting data, the type of data we collect is important because it determines what we can do with it. So let's look at some types of data that we collect. The first type is called categorical. Categorical data is where you count objects or words or properties of something. So for example, the colours of a car, or the colours of someone's hair, or how many A, B, C, D, E grades are on reports. Those things that we're counting are not numbers. There are two types of categorical data. Nominal, where we're counting things due to a property they have. For example, types of dogs, or people with brown eyes. With ordinal categorical data, there is some sense that they have value, but not using numbers. So an example of that would be reports that students get where you say excellent, very good, unsatisfactory. All those things mean something, and excellent is better than very good, but it's not a number. The second type of data is called numerical, and that comes from the word number. Data you can measure with a number. For example, the height of something, the temperature of something, the number of goals kicked each game. There are two types of numerical data. Discrete. Discrete data is in whole numbers or integers, and there's no in-between values. For example, points scored in a game. If I'm playing basketball, I can't get 3.5 points or 3 3/4 points. I can only get 3, 2, whole numbers. Continuous is when you can get all those fractions in between. So numbers that have fractional values or decimal values, for example, heights of students. A student can be any height, for example, 1.74 metres, 1.75 metres, 1.755 metres, etc. All those fractional values are able to be measured. Another example is the distance a javelin's thrown. So discrete are fixed numbers with no in-between values or fractions possible, and continuous can have all the fractional values in between. When we collect our data, we like to arrange it, and we arrange it in tables and graphs. So the first one that I'm going to look at is a frequency table, and this is it here. It's got the thing that we're interested in and how frequently it turns up, and can include a tally where you're counting as you go to see the final frequency. A dot plot is a graph which uses dots to show how frequently each item is counted. A pictogram uses a graphic, in this case a picture of a pizza, and the picture of a pizza is worth 4 pizzas. A histogram is a graph where there are vertical bars. A pie chart is a round circle which is cut up into slices of a pie based on the percentage of each item. And a stem or stem and leaf plot actually uses the numbers to do the graph. So this value here, which says 4, would be 44. So you can actually look at the numbers and the graph at the same time. When we graph our data, we can either end up with a symmetric distribution or one that's skewed. In a symmetric distribution, both sides of the graph have similar gradients, although one's positive and one's negative. You can see it also in this graph here, which is called a normal distribution. Walking up this hill would be just as hard as walking up that hill. A skewed distribution is not like that. One side is much steeper than the other side. For example, these graphs underneath, you can see this would be easier to walk up than this part here, and the same here and here. So a skewed distribution has its maximum value towards the side rather than in the middle. This is called a negative skew because the tail is sticking out to the negative side. This is called a positive skew because the tail is sticking out to the positive side more. The other thing that can happen with distributions is you can get something called an outlier. An outlier is a number that doesn't fit in with the rest. So this number here, or this result here, which is between 75 and 79, does not look like it fits at all with all these other ones down here, which are below 64. When we look at our data, we often look for a number that represents the lot. So we call those averages. So here are 3 sorts of averages. The mean, which people often call the average, is when you add up the numbers, divide this answer by how many numbers there are, and that gives you your average, or your mean. The mean of these 3 numbers, 1, 3, 5, would be worked out by going 1 plus 3 plus 5, dividing by 3, and you would get 3. The median is when you put the numbers in order and find the middle one. So if I put all these numbers in order, the middle number is 3. If I do the mode, it's when I look for the number that is there the most. So in this group of numbers here, there are more 6s than anything else, so the mode is 6. We often want to know how spread out numbers are, so we can use the range or the interquartile range to do this. The range is the biggest number, take away the smallest number. So for this set of data here, it would be 6 take away 1, which is 5. So 5 is showing how spread out those numbers are. To find the interquartile range, you need to find the lower quartile and the upper quartile. For the set of data that I've got at the top of the page, 3 is the median, 2 is the lower quartile, and 5 is the upper quartile. You can see I've split those numbers up into quarters. So the interquartile range would be 5 take away 2 equals 3.